So for this integration by parts, it's going to be a little more like a double method, if you will. So first of all, we notice we have two functions that are not the derivative of each other. I notice there's a trig function and a polynomial. So since polynomial comes first, my polynomial will be what I choose for my u. X is my polynomial, the derivative of that is 1 dx. And the leftover will be my dv. So cosecant squared of x dx. Now, we do have to think what trig function has the derivative of cosecant squared. Well, we know tangent's derivative is secant squared, or at least we should. So cotangent's derivative is negative cosecant squared. So negative cotangent is our antiderivative of cosecant squared. It will be super helpful if you have most of those trig functions derivatives down, so at least you could write the derivative down and then go backwards. So I have my u, which is x, times my v for negative cotangent of x. Remember, that's because I'm now following this formula. I've got my u and my dv identified. So the formula is u times v minus the integral of my v function, which is negative cotangent of x, times du, which is just 1 dx. Now if I rewrite this, I'm going to bring my negative constant out front and call it negative x cotangent x. And my negative times negative will make this a positive integral of cotangent x dx. So in this case, it kind of looks like, gosh, we should know something whose derivative is cotangent, but we don't. So, fun fact, we actually get to use substitution. Let's take a little side tangent over here. Tangent, pun intended. Cotangent of x is actually cosine over sine. We probably haven't thought of this, but if we let u be the sine, so we're going to integral cosine of x over sine of x dx. Same thing as cotangent, remember. We're going to let u be the sine because we talked about how picking the u for substitution, denominators are a great choice. Well, if I derive that, the derivative of sine is cosine, and how convenient that I actually have cosine x dx up here. So I'll actually rewrite this using substitution as the integral of 1 over u, because my sine is in the denominator, and cos x dx, or cosine x dx, is replaced with du. Again, cosine x dx can be replaced with du. Well, if we remember whose derivative is 1 over u or 1 over x, that would be natural log of u. And of course, putting in our u value then, we would have natural log, the absolute value of sine of x. Fun fact, we just anti-derived cotangent. So we're going to use this, that was all a tangent, right, of anti-deriving cotangent. Our final answer for our first integrand has our u times v still there, bring that down, don't forget about that, plus the natural log of the absolute value of sine of x plus c. And if that wasn't fun, I don't know what is. Using one method is fun. Using two methods is even more fun. Take a look at this example in around page 62, number 5, on the integration by parts classwork. Try it on your own. Use this if you get stuck.